Okay, so we are back with calculus after a long time. In today's video, we are going to see some free fall applications. We are going to solve 3 problems on this. And this is the first one, the 10th one. Here, a rock is thrown vertically upwards from the surface of the moon at a velocity of 24 meter per second, and it reaches this height s equals 24t minus 0.8 t square meters in t seconds. So the displacement or height as a function of time is given to us. And there are several parts. This is the first one. We have to find the rock's velocity and acceleration at time t. So this is a simple one. Since displacement is given, the velocity will be obtained by differentiating once with respect to time. And then if you differentiate once more with respect to time, you get acceleration. So let's solve this one first. You can write, actually you should write the velocity is, I'm not going to write those sentences. Okay, let me straight away do the calculation. So s is 24t minus 0.8 t square. So differentiating it, we will get 24 minus 0.8 times 2, that is 1.6, and then t square will become t. And do not forget to write the unit, meter per second. Okay, so this is the velocity at the time instant t second. And the acceleration is obtained by differentiating v with respect to t. So this gives us what? Minus 1.6 meter per second square. Okay, so 24 vanishes because it's constant. Differentiating it, it vanishes. So that is part A. Next, let's see part B. How long does the rock take to reach the highest point? How long does the rock take to reach the highest point? When the rock goes up, as it is thrown, it will go up, and in doing so, its velocity will gradually decrease, and at some point it will stop momentarily, and then immediately it will start to fall down due to gravity, moon's gravity. So what happens when it reaches the highest point? At that point, the velocity is 0. So we want to find that time instant, and for that we have to see when the velocity becomes 0. So at the highest point, v of t will have to be equal to 0. This means 24 minus 1.6 t needs to be equal to 0. And if you solve this for t, you will get 15, I think. Yes, 15 seconds. That means the rock will take 15 seconds to reach the highest point. Next, C. How high does the rock go? So obviously here we need that height. that the rock reaches in 15 seconds. So for that, what should we do? We have to calculate the displacement function by putting t equal to 15. That's it. So the maximum height the rock will reach is S15. And if you do the calculation, you will get the value 180 meter. Okay, you please do the calculation and verify that you really get 180 meter. Then let's see part D. How long does the rock take to reach half its maximum height? Okay, so the maximum height is 180 meter. How long does the rock take to reach a height of 90 meter? So that means again we have to calculate the time instant when that height is reached. Now if you again consider how the rock is moving, what does the rock do? It first goes up and then again it comes down. So it goes up from the surface of the moon because it's thrown from there. It reaches the maximum height 180 meter and then again it falls down. And in doing so, the height of 90 meters is reached twice. Once when going up and once when coming down. And accordingly, if you solve the equation that s of t equal to 90, you will get two values of t. So those two values will indicate those two instants of time when that height is reached. One of them will be when going up and that time will be shorter, and the other one, which again you get that height while the rock falls back, that is the longer time. Let's see what values we get. So that means this is what you now have to solve. You have to solve this equation. In other words, 24t minus 1.6 t square equals 90. Now I am of course not going to solve it here in detail. It's a quadratic equation, you can solve it yourself. And the values that you are going to get ultimately are these. Approximately. Okay. One of the values is 4.39 second. And the other value is approximately 25.6 second. So when the rock goes up, it reaches that height 90 meter in 4.39 second, and then it reaches maximum height 180 meter, and then again while falling down, it again reaches that height of 90 meter, and in getting to that instant of time, 25.6 seconds have elapsed. Okay, so these are the two time instants. Then finally there is another one, E. How long is the rock aloft? Aloft means for how long is it in air? Okay, so it goes up and then comes down. What's the time that it will take to make that complete journey? For that, you have to solve this equation. Why though? Because do not forget that S is not the distance covered by the rock, S is the displacement. So when the rock goes up and then finally comes down, its displacement is 0. At the instant it hits the ground, it has come back to its original position. So if you solve this equation, that is 24t minus 1.6 t square equals 0. This one is easier to solve because you can already see that t equal to 0 is 1 root. T equal to 0 second, or there is of course another value, and that value I hope I have here, 30 second. And these two times indicate, you see, t equal to 0 is the instant when it did not actually leave the ground. So that was the start of the journey. At that point there was no displacement, and then when again it came back to that same position, again there is no displacement. So in total it takes 30 seconds for the rock to make the complete journey. Okay, so this is your number 10. I hope you can write the complete solution by writing sentences in a nice way. That you can do. Okay. Let us next see number 12. Yeah, instead of writing down the question itself, let me just read it out. Explorers on a small airless planet. Okay, so there is some airless planets. So this is a portion of the surface. There is no air, there is no atmosphere in the planet. Maybe it's a rocky planet, a small one, like our moon, although moon is not a planet, but just I am saying that there is, the gravity is so weak that there is no atmosphere. So what happens is that explorers are there and they have used a spring gun which uses spring to launch a ball bearing vertically upwards. So here you have the spring gun, whatever it is, and a ball bearing has been launched vertically upwards from the surface at a launch velocity of 15 meter per second. Okay, so just like that one was launched at a velocity of 24 meter per second. Alright, and the planet has its acceleration due to gravity gs. This of course need not always be 9.8 meter per second square. That is on Earth. Different celestial objects will have different values of this acceleration. So, according to the equations of motion, the explorers expected the rock to cover this distance or this height in time t, because it started with this velocity minus 1/2 gs t square. Okay, so this tells them how high the rock goes in time t, if this is the initial velocity. You already know how this equation comes from your knowledge of school physics. We, however, need not worry about those things here. Okay, it's already given to us. And of course, this is in meters. So this many meters the rock, the ball bearing goes up in t seconds. Alright. Now, and they found after this thing that the ball bearing reached its maximum height in 20 seconds. Maximum height was reached in 20 seconds, then what is this GS? What is the value of this acceleration due to gravity on that planet? Recall that maximum height, just now we saw the max, at the instant the maximum height is reached, at that instant velocity is 0. That is the only point during this type of journey that the velocity is 0. We are given displacement, so we need to know the velocity first. And you are going to get that by differentiation. So V of t is ds dt. What will you get? From this term you are going to get 15. Gs of course is a constant. If you differentiate t square, you will get 2t. That 2 and this 1 over 2 will cancel each other. So that means you are getting Gs t. Okay. And it's given that 20 seconds are needed for the ball bearing to reach maximum height. So that means V of 20 should be equal to 0. So this means 15 minus 20 times Gs is equal to 0. Now if you say, yeah, this one looks simple enough. So Gs will be 15 divided by 20. If you do a little cancellation, if you cancel 5, you are getting 3 over 4, which if you express as a decimal, it becomes 0.75. And what will be the units? Unit, it will be meter per second square. Yeah. So this is the acceleration due to gravity value. So you can see that it's quite weak. Here we have 9.8 meter per second square, here only 0.75. A small planet. Let us next see 16. And this one is free fall from the Tower of Pisa, the Leaning Tower of Pisa. You already know, it's a famous thing. Okay. So what this one says, again I am not going to write the question, it's already available in the book. Let us actually see what it talks about. Had Galileo dropped a cannonball from the Tower of Pisa, so this is the situation now. Say you have the Tower of Pisa here, Leaning Tower of Pisa, and Galileo dropped a cannonball from the top of this tower 179 feet above the ground. Okay, so that's how high the tower is, I mean in its leaning position. 179 feet above the ground. The ball's height above ground t seconds into the fall. So the cannonball is falling, and say after t seconds it reaches a height of s. Yeah, the diagram is a little messy admittedly, but you get the point that after t seconds it reaches this height. Here we are not talking about how far the cannonball fell from Galileo, but we are talking about the height of the cannonball above ground. So as more and more time passes, the height will decrease, and it's given. Okay, so this S is 179 minus 16t square. So in this expression, I mean in this formula itself, you can see this, that when t is 0, the height was 179, and then as t becomes larger and larger, this reduces. Part A. What would have been the ball's velocity, speed and acceleration at time t? Okay, three things: velocity, speed and acceleration at time t. That is part A. So let's calculate. Velocity is ds dt, so that is minus 32t. And don't forget, the distance is being measured in feet, not meter. Feet per second. Then speed. Speed is the absolute value of velocity, which in this case, I mean it's a little different because this is minus 32. So this will be 32t feet per second. And acceleration. Acceleration is dv dt. So this will be, do not differentiate this one, okay. You have to differentiate velocity. Minus 32, acceleration is constant, feet per second squared. So that is A. We have learned quite a lot about differentiation. There are other things also to learn. So differentiation allows you to know velocity and acceleration when displacement is given. But if these things are given instead and you have to go back, say acceleration is given, you want to know velocity. For that, you need to know integration, which will come. Okay. Next, what is B? About how long would it have taken for the ball to hit the ground? Okay, how long does the ball take to hit the ground? So for that, you can just simply calculate S equal to 0. S equal to 0, I said. No, that's not. Is that correct? I am also getting a little confused. Oh, see, just now I told you that S is not the distance from Galileo, and I myself am getting confused. Yes, when the ball hits the ground, S will be equal to 0. So that means this is what you need to solve in order to know when the ball hits the ground. In other words, 179 minus 16 t square is equal to 0, and that will give you only one value of t. See, as an equation you are going to get two values of t, but one of them will be negative, which does not physically make sense because t is time. So the value that you are going to get is approximate. So it is something like this: 3.34477 second. This much time the cannonball is going to take to hit the ground, to come down fully. If you want, you can neglect some I have shown 5 decimal digits, that's not necessary. Okay, so that is part B. And finally part C. What would have been the ball's velocity at the point of impact? You can, you know from experience that as the ball falls, its speed increases and increases, and finally when it hits the ground, it reaches its highest speed possible in this situation. So what is that speed? That speed, of course, is this. Because this value itself is approximate, so the speed will also be approximate, and further will be approximately equal to 107. So I am just directly giving you the values. So the verification of these numerical things are left to you. Feet per second. Okay, so 107 feet per second. So that's the high speed, and if this cannonball falls on someone's head, then it will hurt. Probably that person will die. But anyway, so these were some problems on free fall of objects under the influence of gravity. And as usual, tomorrow we have, I remember, yes, it is what we have tomorrow, linear algebra. Okay, so see you tomorrow with that. Until then, this is me, Lucifer, from A Mathematical Room. Have a nice day.